All right, so here we go. So the last chapter, the last is the very last chapter we're going to do in this class is dealing with statistics. Okay, it deals with statistics. What is statistics? Well, statistics is one thing. It's how do you analyze numbers? We have some numbers here. These are the numbers you guys put in from the survey, right? What day of the month were you born? These are the numbers. Each number represents one of you guys, right? Each one of the numbers represents one of you guys. Um, so your thrown numbers, a lot of you are given, like, especially with this day and age where you have access to information, your phone, you're thrown data at you all the time. And you have to analyze it. You have to go through it. Because if you don't make good decisions, right? For example, one of the things you have to do is when you're an adult. Some of you might even have to do this right now. Um, if you have to pay for your own, let's say you're a driver and you have to pay for your own gas, right? Some of you might have to pay for your own gas. Um, if I have a car and that car needs to be filled with gas in order to run, I have to analyze how much I spend in a month. So at the end of the month, I'm like, okay, this is how much money I spent on my gas. If you can afford that, great. If you can't afford that, you're like, I can't keep doing that. Then you have to adjust to make decisions, right? Or else you're going to run out of money. Especially if you have to deal with things like mortgage or rent, because once you get older, if you don't live at home, you have to pay for your own way, right? You guys get older, that's just going to happen. Okay. Same thing with like cell phones. Same thing with like if you have, what kind of apps, Netflix, all those different things that you guys like, that we all like, those things cost money, right? So you got to analyze that. And that's part of being an adult. Okay. Um, Today, what we're going to analyze is not money. Most of the time when you're an adult, that's what you have to analyze, money, right? Because very few people can afford everything, right? Most people have a set limit you can't really go over. Okay, it's called a budget. Most of us have budgets, or you guys will have budgets when you guys get older, and you have to live within your budget. Okay. Um, so today we're not going to analyze numbers, or sorry, money. We're going to analyze numbers, dates of you were born. Okay. So these are the days here. So the first thing we're going to do, there's a couple different ways we can analyze these. First way is we can find the average, right? I can find the average date that you guys were born. How would I find the average? There you go. Add them all up. So add up all of these numbers. Don't do it, but you would add up all of these numbers and you would divide by 19, because I think there's 19 numbers. That's one way, right? That would be the average day. Another way is to find the median. What's the median? The number in the middle, right? We could do that. That's another. There's two ways to describe the middle. One is the average, one is the median. We'll do that later. You could do different things like that. Okay. So today, what we're going to do is we're going to show visually what these numbers look like using two types of graphs. Actually, three types of graphs. The big ones are the histogram and box plots. Okay. The first graph is probably the easiest graph. That's why I start with it. So if you look down here, you get a number line. So the first one we're going to do is what's called a dot plot. A dot plot. We're going to make dots for the numbers. Okay. So for example, or you can use X's as well. You can use dots or X's. So first person is 26. So I'm going to go over here and make a dot at 26. The next person is 18. So I'm going to go over here and make a dot at 18. Right? And I'm going to keep doing that for every single number that's in the table, because that represents a person. Okay? Try to make the dots as close to the same size. Okay, so I have two 18ths. Two people were born on the 18th, but I already have a dot at the 18th. So what do I do with the dot? Stack it. Yep, stack it. Some people might say, oh, you already have a dot. You don't have to write. Well, no, because you have two people, right? If I only have one dot, that means there's only one person. That's not right. There are two people who have on the 17th. Oh, sorry, the 18th. I have two people on the 13th, so I'm going to stack those. 2 people on the 20th, stack those. 2 people on the 19th. 2 people on the 22nd. And then I have a third person on the 13th. I think that's it. Okay. That's one graph. It's a visual. There are numbers on the number line, but I don't actually see the numbers. I have dots instead. Okay, so how do we analyze graphs? There are there are more than 3 ways. 3 ways we're going to do it today. First thing is clusters. Clusters. Clusters are groupings. So where would you see a big grouping? Where's the biggest grouping of dots? So yeah, I would say this group right here, right? This cluster here. That's a big cluster, right? That is, what is that, 9? 9 out of 19, that's more than half. More than half are clustered there. So I would say that's a cluster. Any more clusters? There's a cluster here, right, at 13. We have a special name for that cluster. It's called the mode. The mode. Mode means the biggest. Anytime you hear the word mode, think of this. That means the most. Where's the highest? 13. Okay. Gaps. The next one is gaps. Where do we have gaps in the data?
On the far left and right.
So give me numbers.
The dots are only where the numbers, there's only one dot high.
Okay, so where are the gaps though? Where are the gaps in space?
3, 6, 7.
Well, there's not a gap here because there's not a gap at 1 because there is a dot at 1. I'm talking about where are the areas, large areas where there are no dots. Yeah, sorry. 27, 28, there's a gap here. Yep. I would say there's a gap there. Where else is there a gap? Yeah, 22, after 22 to 26. Yeah, Brian? There's another gap here. Yep. Where's the other? 4 to 5. There's a gap. Yep. And then this is, I think, the last gap right here. Right? All of those are what we call gaps. We don't really say there's a gap at 2 or 7 because that's just one number. But anything bigger than that, we could call gaps, right? There are gaps there. Okay. Range. The other one that we're going to look at today is range. Range is probably the easiest thing to calculate because the formula is very, very simple. Range is the biggest minus the smallest. The biggest minus the smallest. So what is the biggest number we have on our sheet? 29, right? Minus the smallest. What is the smallest number we have on our sheet? So the range would be 28. We'd have a range of 28. Range, so anytime so if you're talking about mode, I'm going to go like this. I'm going to say high as I can. If you're talking about range, I'm always going to do this with my hands. I'm going to separate them. That means how far is it from one end to the other end? Okay. Okay, so good. Middle, we kind of talked about the middle. We'll talk about that later. The next thing I want to talk about is the bottom of the page. Shapes. We got 4 shapes. Let's focus on the first 2. Let's focus on the first 2 shapes. Skew to the right and skew to the left. They both have the word skew. The only difference is the right and left. So if you were describing the difference, how would you describe what is different about those 2 shapes? Because there are differences, there are similarities. What is the differences between these 2 shapes here? Yeah, one's going to the right. This is the way I describe it to students. If this was some of you might ski or you've seen skiers. If I'm skiing on the skew to the right, if I'm up here, which way do I want to ski? Unless I have a death wish, I'm going to go to the right. Because this here, yeah, it's just death. That's a cliff, right? That's not skiing. It's called dying. Okay. So if you were skiing, you would ski to the right. That's why it's called skew to the right. And if I'm over here, same thing, except you're going left, right? You're not going off the cliff. You're going this way. So that's the way I memorize it. Skew to the left, ski to the left, skew to the right, ski to the right. Okay? So yeah, definitely. That's the difference between them. What is causing that? What is causing that, like skew to the right? What is causing? Why is this hill big?
Well, because there's more numbers.
There you go. We got a lot of numbers. And where are those numbers located? On the lower part, right? The lower numbers, right? Majority on the lower numbers. What about skew to the left? Okay, so let me ask you this question. Let's say we take a test. Which would you rather have your class, skew to the left or skew to the right? Right, skew to the left, you'd rather have them because that means most of you scored a lot of A's and B's. Are there C's? Yeah, there's C's, but not as many, and even less D's and F's, right? That's what you want. Skew to the right, something went on, right? Skew to the right means almost everybody or virtually everybody got a D or an F. Are there C's? Yeah, there are C's, but not that many, and even less A's and B's, right? That's not good, right? If that happens, I do this every test or every quiz. I always do this. I have a program where it does all of this and puts all your numbers in and it gives me a graph. And I look for shape because if your numbers are like that, something went on. Either um, either you weren't prepared or there's something on the test that I didn't teach. Okay? There's something going on. Some people say, well, we didn't study enough. Yeah, that's true, but that might be true, but this is overall. There's always going to be one or two or three or four people who don't study and they get a low score. But the majority, even if they don't study, it's because they were prepared. So, it's a way to look at a bigger picture. I'm not looking at one student. I'm not focused on that one student out here that got an A. I'm not focused on the one student who got an F. I'm focused on the majority. Where's the bigger picture? Okay? Most of our tests are like this. Most of our tests are like this. Most of the scores are in the A and B range. And then I have some C's, and then I do have D's and F's. Now, I'm not focused on the D's and F's because there's not that many of them. Okay? So that's skew to the right and skew to the left. Symmetric. So now the last two. They're both symmetric, but they're different symmetries. They're different. First of all, what does symmetric mean, or symmetry? What is symmetry?
When each side is the same.
There you go. Cut it in half, you have exactly the same on both sides, right? If I fold this in half, it's exactly the same on both sides. That's symmetrical. Okay. They're both symmetrical, right? The left one I could cut in half, it would be right in the middle. And this one I could cut in half too, it would just have two peaks. Okay? So symmetric has only one peak. And where is that peak? Right down the middle, right? Right down the middle. Bimodal has two peaks. There, that word mode. Two peaks, right? That's what mode means. Where's the peak at? Where's the high point at? Okay. All right. So have you guys ever heard of curving a test? Have you guys ever heard of teachers saying, I curve the test, or I'm not going to curve the test, or curving, some sort of curving test? Okay. What does that mean? This is what it means. It means making your data look like this, right? So if we took a test and the data looks like this, where the majority of people are right now is a D and F. What I'm going to do is I'm going to have a sliding scale. So those D's and F's now become C's, right? That's what a curve does. Now, you only curve when you need to. Like for our tests, I've never curved one test because for the most part, you guys are like that. If I were to curve this, these A's and B's, guess what they would become? They'd move to the middle, C's, right? And you don't want that. You earned an A or a B, so you're going to keep it. So why would I curve a test if it looks like that, right? So that's why teachers curve tests. Like in this class, I don't curve tests, but in my calculus class, I do have to curve sometimes. They don't look like this exactly, but there's, there are some times, there are some tests, because on your tests, you guys get partial credit, right? They don't get partial credit on theirs. It's either they do it right or do it wrong. So sometimes they get close, but they lose all of their points because they weren't close enough. So it's tough. Okay. So for this class, you guys, I don't need to do that, but that's what curve means. Well, where does the word curve come from? Right here. It kind of looks like a bell, right? Like a bell like you ring. It's called a bell curve. That's what it's called. Back in my day, they called it a bell curve. Well, since I've been in school, they dropped the bell part and just call it a curve. Teachers say we curve the test. Okay, that's what they're talking about. Okay, making it look like that. Perfect test. On a perfect test, most of the students would be in the middle. C's. There would be the same amount of A's and B's as D's and F's. Very little, right? That's the perfect test. Our class doesn't do that. That's why I don't curve the test. Our class, no, see, the only reason you curve a test is if you have stuff like this, right? That's why I don't curve our tests. There's no need to, because it looks like this. If I were to curve our tests, a lot of you who got A's and B's, your grade would go down. That's not fair. You guys earned your grade, right? Mhm. Well, that's your version of the perfect test. In my eyes, that would be an easy test. Too easy. I'm like Mr. Flores. Yeah, if everyone got an A on the test, I would, in my mind, I would say you didn't make a hard enough test. That test was way too easy. I don't know. Maybe on some quizzes. But yeah, I don't think on tests, no. But yeah, that would just be like, that would be, to my mind, skew to the left is not bad, especially for you guys. But for a teacher, I want to push you guys so that you're pushing yourselves, right? So I would just say, okay, next time I need to make tests a little harder. Okay, if that happened. What if everyone got an A on the final? Then I can't do anything because that's the last test, right? I'm like, good. I would look at the test. I would look at the test and see if there's any abnormalities. If there's not, you got what you got. Some, like, if nothing like that happened, then you guys earned your grades. Okay. Okay, so here bimodal is kind of like that, but it would be like if A's and D or B's and D's were the high points, right? B's and D's were the high points, right? B's and D's are kind of the same, they're just on different sides. Like A's and F's, they're both extremes, right? A's is extremely, knew it extremely well. F's are you didn't know it extremely, you knew it extremely bad, right? They're both extremes. B and D are kind of the same. They're not extremes, they're above. So B's are above average. D's are below average. They're not terrible, but they're below average. And then C's are average. So not a lot of C's, a lot of B's, a lot of D's, a few A's, a few F's. Okay, that's what that means. So now let's look at our data. For this one here, no, a perfect test, no. Yeah, so if it's a perfect test, meaning the right amount of hardness would be that. But again, I'm not going to make tests harder to make that. So it is what it is. Okay. Okay. So our data. Now, nothing's perfect in this world, especially real numbers. They're not perfect. But if you had to describe, what would you say? What shape would you say our data represents? Would you say it's skew, or would you say it's closer to symmetric? I would agree. I would say closer to symmetric. Here's the reason why. And you're going to explain to me next. So pay attention to this explanation. I would say the reason why it's closest to symmetric is because the most amount of data, there's bigger clusters in the middle. The clusters here, these two clusters are in the middle, right? There's some out here, there's a couple over here, but the clusters are in the middle. That's where the clusters are. The clusters aren't on the low side, and they're not on the high side. Okay, that's how I would explain. Here's the thing about statistics. Statistics is a lot less math, a lot more explaining your reasoning. Okay? So on tests, I might take more than one answer because you explained your reasoning well. Okay? So some people like that. Some people like, look at the only math we've done so far is what? That. We're adding, subtracting, multiplying, dividing. That's about it. We don't do any crazy square roots or what. We don't do any of that stuff. We don't. Common denominator. We don't do any of that stuff. We do a lot of easy math, but you have to explain yourself. You have to explain yourself. Some students don't like explaining themselves. Some people like say, give me the math, give me the numbers. Some people are like, you know what? I'm not so good at the numbers, but I can explain myself very well. You'll be fine here. Those are the students that like statistics more than other things. Okay? All right, so let's turn to the back. Let's turn to the back. Okay, so there's two graphs we're going to draw. We're going to do histograms today, box plots we'll get to tomorrow. So histograms, there's 6 steps for histograms. The first step is I need to create intervals. Intervals are smaller pieces, smaller chunks. I'll give you an example of an interval. You guys go to school from 7:25 to 2:40, but that's broken up into intervals. What are those intervals called? Periods, classes, lunch, right? Broken up into smaller pieces, right? That's what intervals are. Something big broken up into smaller, equal sized pieces, right? Periods are the same size. Okay. Period 2 is a little longer because we have announcements, but besides that, it's all the same size. So let's look at our numbers. What's the lowest number again? What's the biggest number? 29. We need to cover from 1 to 29. So that span is 28. So I have to have at least 5 intervals. So how big should those intervals be? Can I have just one interval, 1 to 29, and say that's an interval? No, I can't, right? Because that's not at least 5. That's one interval. So I have to break it down into smaller. So what size would our intervals be? Let's say 5. Let's say 5. So if I started with 5, don't write this down yet. We'll write it down together. So if I said 5, start with 1. 1, 2, 3, 4, 5. It goes to 5. With the next interval, where would it start from? 6, right? If you're not born on the 5th, you got to be born on the 6th, right? 6, 7, 8, 9, 10. It would go from 6 to 10. Okay? The next interval would start at 11 and it would go to where? 11, 12, 13, 14, 15. Am I done or do I have to keep going? I have to keep going because there's people that were born after the 15th. 16 to 20, 21 to 25. Can I stop or do I have to keep going? 26 to what? Not 29. 30. Yep. I have to go to 30 because I have to make them all the same width. Okay. Now, is there anyone over the 30th? How many intervals do I have? 1, 2, 3, 4, 5, 6. Is that at least 5? Then I'm good to go. Okay. So let's write these down. So step 2, make a table. So we're going to make a table with 4 columns. Okay. So what I want you to do right next to the steps, you're going to make a table because we need this area over here. Over here, we need this area. So you're going to make a table next to your steps. Don't make it too big. Watch. I'm going to zoom in, so mine's going to look a lot bigger than yours, but don't make it too big because we got some stuff to write. Okay, there we go. Just like that. Okay. Now, each column represents something. So the left column, the very left column, is our intervals. So these are our intervals. So our first interval was from 1 to 5. So now we're going to write it down. From 1 to 5, and I'm going to draw a line underneath. Then our next interval was 6 to 10. 11 to 15. 16 to 20. 21 to 25. And the last one was 26 to 30. Okay. So we have at least 5. I have 6 of them. That's okay. I can have more than 5. I can have 5. I can have more than 5. Can't have less than 5. Okay. That's the first column. The second column is what's called frequency. Frequency. What does frequency mean? There you go. How often, right? Frequent, how often it happens. So let's go to our numbers. How often did I have a student who was born from the 1st to the 5th?
Yeah.
I had 2 students. So I'm going to put a 2 there. It's kind of like a tally marks, tallies. In other words, sometimes you'll see tallies instead of frequency. It's the same thing. So how many students did I have that were born from the 6th to the 10th? Okay. So you're counting up all the dots on the 6th, the 7th, the 8th, the 9th, and the 10th. 11 through the 15th. How many dots from 11, 12, 13, 14, 15? Okay. 16 to the 20th. 7? Okay. Let's see, 21 to 25. 2. And then 26 to 30. 2. Now, all of those numbers, if I added up all the frequency numbers or all the tallies, what should that equal exactly? The total amount of students who I had. I better not go over 19. So if I add them all up and I get 19, I can go on. If I don't, I made a mistake somewhere. So let's see, 5 plus 10 plus 4, yep, 19. Good. Okay. The next one you're going to need your calculators for. So if you have your phone, we're going to use the phone. So, okay, so the next one is called, it's got frequency in it, but now it has a relative frequency. It has the word relative with it. Relative frequency. Not like a relative, like, like your grandma or something like that. It's not relative like that. It's a different type of relative. What is relative frequency? Well, this is what relative frequency is. Let's say I go and tell Mr. Yates next door, hey, guess what? I have 3 students who are born between the 11th and the 15th. First thing he's going to ask me is that a lot? 3? Well, if I only have 4 students in the classroom, that is a lot, right? So what relative does is makes it so that we can understand how important that number is. So what do we use? What's a way of figuring out if 3 is a big number? Division, yeah, division. We can divide by the whole, right? So let's do the first one. The first one is 2. I'm going to divide it by 19. It's going to be a decimal. I'm going to go 3 places. So let's see here. So I'm going to go 2 divided by 20, or not 20, 2 divided by 19, and I get a decimal here. I'm going to go 3 places past the decimal. So 1, 0, 5. The 2 behind it says stay. So I'm going to write down on my paper 0.105. Okay, 0.105. Okay. The next two are the same. So once I do one, I can do the other. So I go 3 divided by 19. Yeah, exactly. Three divided by 19. So this one is 157. The number after it is 8. So that means that 7's got to go up to an 8. So 158. 158. Okay. Now the next one is 7 out of 19. Seven divided by 19. The biggest one so far, 0.3684. 4 is less than 5, so I'm going to leave 8 the way it is. So 368, 0.368. The last two are just 2, so it's going to be the same number. So 2 divided by 19. 2 divided by 19 is the same number, right? Didn't we already do 2? Yep. So, yep. There we go. Okay. Done. Done with that column. All right. So now all of the numbers, all the decimals, we got decimals now, right? All of the decimals should equal what? 1 whole. They should equal 1 whole. They should equal 1 whole. Let's say they equal 0.999. Is that okay? Yeah. Why is that okay if it's really close to 1? Because all of these numbers, what did I do to all of these numbers? I rounded them, right? I rounded them. Okay. And then the last one is percent. So change each decimal to a percent. So 0.105, I move the decimal over twice and I get 10.5%. The second one, you move the decimal 2 times to the right and you get 15.8%. Same thing here. Then you get 36.8%, 10.5%, and 10.5%. Okay. So that is step 1, 2, 3, and 4. We just did steps 1, 2, 3, and 4. The last 2 steps are the actual graph. The table's the hard part because the table is the actual numbers. The graph is not that bad. You just have to actually draw it. Okay, so how do you draw this? Well, you need an X and a Y. So over to the right, I'm going to draw an X and a Y. Okay. So there's 2 things I'm going to graph. The bottom is the X. The X is the one that goes from side to side. That one, so the one that goes here, that's the X-axis, right? That's going to be the intervals. The intervals. So always at the start is 0. The corner is 0, 0, right? The first interval is from 1 to 5. So 1 is just a little bit past 0. There's 1. And then 5 is about here. So I'm going to say this is from 1 to 5. That interval is from 1 to 5. And then the next one is from 6 to 10. And then the next one, 11 to 15. Going to keep going until you get all of them. Okay. So we got all the intervals now. So that's the x. That's how we label the x-axis. Now we got to label the y-axis. Well, the y-axis is going to be relative frequency. It's going to be relative frequency. So I'm going to use this guy right here. I'm going to graph these numbers, these decimals, over here. So I look at these numbers. They're decimals. They're all smaller than 1. The biggest one is 0.368. The smallest one is 0.105. So I'm going to go by 0.1 or 0.100. Okay. I'll stop there because none of them go above 0.400. None of the numbers do. And we say this is relative frequency. Okay. The last part, you're just drawing the bars, drawing the bins, drawing the intervals. So 1 to 5. 1 to 5, interval 1 to 5 went up this much here. So I'm going to go up a little bit past 105 or 0.100. So that's a little bit above that. Okay, 6 to 10 was a little bit more. The next one was exactly the same height. The next one, 16 to 20 was the tallest. That one's almost to the top. And then the last two are the 10s. 0.105. Okay, I'll stop right there and let you guys catch up. Okay, so now this kind of looks like a graph you've seen before. What type of graph does this look like? A bar graph. It looks like a bar graph. You guys have been doing bar graphs since elementary school. I think that's where they teach you how to do bar graphs, right? So why is this have a special name, and why are we doing it in Math 3 and not elementary school? Well, there's a couple key differences. The first key difference is that you have intervals, right? The bars on bar graphs don't touch, right? They don't touch. On histograms, they do touch. They need to touch. So what do I mean by touch? They butt up against each other, right? Why is that needed? Something about a whole number. So let's say I was born on the 5th. I would be in this first bar, right? What comes after the 5th? So that means I'm in a completely different bar, right? I'm over here. Can I be born on 5.5?
No.
Right? You're either born on the day or you're not born on the day, right? So if I'm born on the 5th, great. If the day clicks over to the next day, it's no longer the 5th, it's the 6th, right? So there is nothing between day 5 and day 6. There is absolutely nothing in between them. That's why they have to connect. Okay? There's no gap missing. Because if I have a gap between the bars, that means there is something between them. There's not. There's not. If I'm born on the 10th or the 11th. I can't be born on the 10.5, 10.3. That's not possible. Okay? You're either born on the day or you're born the next day. Okay? That's the first thing. Second thing is shape. Let's do shape again. What shape best describes? What shape best describes? What shape out of the four we talked about best describes? So my answer, this is the way I always analyze it. Where are the highest bars at? Where are they located? Beginning, middle, end. Where are the highest bars located? Well, first of all, let's start with the highest one. Where is the highest one located? This is pretty much in the middle, right? I would say this is the middle, right? Is it on the high side of the middle? Yeah, but it's still in the middle. This guy's in the middle. And then where are the other bars? One's in the middle. One's it's close to the middle. Not in the middle, but it's close to the middle, right? I said middle a lot, right? So because I said middle a lot, I would say the best one is roughly, is it perfect like this? No, but nothing in life is perfect. Nothing in life is perfect. If I go to McDonald's and buy a hamburger, it's not going to be $1 exactly. It's going to be whatever it is and change, right? Nothing in life is exact. Okay. So if I had to best describe this, I would say symmetrical. Now here's the thing. On tests, if you just said symmetrical, I'll give you 1 point out of 4. You got to explain why. And here comes the explanations again. Here comes the explanations. Why did you say symmetrical? Because most of the big numbers are in the middle. Most of the bars are highest towards the middle. Perfect. 4 out of 4. Okay? There's a lot of leeway here. I'm going to show you, before we do the last thing, we're going to do one more thing, but I want to show you. Here's the last class that I did. I want to show you theirs because theirs looks different. That's theirs. What do you notice about theirs that's different than ours?
It feels like it goes more consistently up.
Yeah, the shape, right?
Yeah.
Where are the highest bars? Still in the middle? Middle edge, right? Middle edge, and then it kind of drops off. So I would say this is still symmetrical, roughly symmetrical. But how many bars do they have? 7 bars. How many bars do you guys have? Is yours right or is theirs wrong? Or vice versa? Step 1. Did they do at least 5? Did you guys do at least 5? So you're both correct. You just did it differently. Okay? So it doesn't matter. The reason theirs is off is because they had one on the 31st. They had a person born on the 31st. So because they had a person born on the 31st, they needed an extra interval. Okay? So that's why there's 7 instead of 6. Let me show you my first class. Theirs looks different than yours too. Besides the highlighting. Yeah, so the shape's a little different. How many bars do they have? 5 bars. Are they wrong? No? No? Okay. The reason they have 5 bars, look at their intervals. What's different about their intervals? It's a little bit bigger. That's what they chose. So they have less bars. It's really in terms of what you want. All of theirs are 6 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All of theirs are 6 wide. All of ours are 5 wide. It does not matter. It does not matter which one is which. Okay? I'm just showing you guys this because they're different ways of doing the same thing. Okay, so when you guys do these on your own, you're going to have to choose how wide is your interval. As long as you have five of them, and as long as they're the same width, I don't care. It's up to you. Okay. Today they were. No, third block is. What's that? Then that's you're not gonna you'll get points taken off because you did step 1. Okay. Oh, okay. That's a good point. So let's say, is this one easier? I would say your 2 are easier to tell what shape. This one right here, that's kind of hard to tell shape because you're like, is it skew? Is it symmetric? The more bars you have, the easier it is to tell shape. So I think third block and what you guys did is a lot better than what they did. Is theirs wrong? No. But it's harder to tell shape. I wish they had done the same intervals you guys did and had more. And yeah. So to get more smaller intervals, yeah. Okay. All right. So we'll finish the rest on tomorrow.